Hello and welcome to a new GCSE revision video. In this video we're going to be looking at the parallelogram. If we distort a rhombus so that opposite lengths are the same but adjacent lengths are different, then we have a parallelogram. A rhombus is a special case of a parallelogram. In short, every rhombus is a parallelogram, but not every parallelogram is a rhombus. But hang on, didn't I just say the exact same thing about a kite? That a kite is also, or that a rhombus can also be described as a kite? Well, yes, a rhombus is a special case of both a parallelogram and a kite. In fact, if an object can be described as both a parallelogram and a kite, then it must be a rhombus and might even be a square. Remember, a square is a special case of a rhombus. A parallelogram has no lines of symmetry. A parallelogram has two orders of rotational symmetry. Opposite lengths are the same size and are parallel. Opposite angles are identical. Adjacent angles add up to 180 degrees, that is to say they are supplementary. The diagonals of a parallelogram do bisect each other, but not necessarily at 90 degrees. The diagonals of a parallelogram do not necessarily bisect the angles. Either diagonal can cut the parallelogram into two congruent triangles. Both diagonals will cut the parallelogram into four congruent triangles. The perimeter of a parallelogram is twice the sum of the two different lengths. Alternatively, you could just go round the outside and add up all the lengths, but remember, opposite lengths are identical. The area is one length multiplied by the perpendicular height. Okay, so I'm going to try and construct a parallelogram. I'm going to draw a line, preferably a straight line. I'm going to take another line of exactly the same length. Now, because these two lines are exactly the same length, when I join them, because these two lines must be parallel, if I can join them at the right position, let me just zoom in a little bit. When joined, these two lines have to be the same length as well, and that's the separation that I made between them, and they must also be parallel. So because these two lines are the same length and parallel, these two lines must also be the same length and parallel. Now, I want to try to prove that the area of a parallel is the base time. The area of a parallelogram is the base times the perpendicular height. So if I can draw a perpendicular height here. Now if I draw another perpendicular height down here, I'm going to use another colour. Now I need this to be an exact straight line. And then this is a straight line. Okay, and now I can erase the bit that's gone over. Alright, so all I have to do now is, if I can prove that this triangle A is the same as this triangle B, then I can effectively say that what we've done is take triangle A and cut it out and move it across to the position of triangle B to create a rectangle. So the area won't have changed for the parallelogram, and the rectangle we know is base times height. Okay, so let's see if we can prove it. Well, we know that this hypotenuse here has to be the same as this hypotenuse here by virtue of, or by the property of a parallelogram. And we know that this height here is the same as this height here. Because we constructed the same height and the same distance between these two lengths. And since this is a perpendicular height, we know that this is a right angle. So by right angle hypotenuse side proof, we know that triangle A is congruent to triangle B. Okay, let me just rub out this, and now I'm going to try something very dangerous. This is either going to be a very visually convincing proof, or I'm going to look like a complete idiot. Let's see how well this works. Actually, I'll keep that in. I'm going to remove this triangle now. So what I said is we might as well have taken this triangle, and if I can figure out how to select nicely. Let's see if I can cut straight up this line and leave a little bit on both sides. This is either going to work or I'm going to look like a complete idiot. Oh, it sort of works. Okay, I hope you can see that what we've got now is a rectangle. Not a brilliant rectangle, but a rectangle. Just going to make that look a little bit neater. So by chopping our triangle off the left and moving it to the right, we've got ourselves a rectangle. And so this is our base. This is the exact same length. This length didn't change. And this is our height. This height didn't change. So the area is just base times perpendicular height. Alternatively, we could say the area is one length multiplied by the other length multiplied by the sine of the angle between them. So area is AB sine theta, where A and B are adjacent lengths. However, if you insist on multiplying the diagonals, the area of the parallelogram is a half times the product of the two diagonals multiplied by the sine of the angle between them. Well, any of the angles where the diagonals meet will be fine, because one angle is going to be theta and the opposite angles are the same and adjacent angles sum to 180 degrees, that is to say they're supplementary, and the sine of 180 degrees minus an angle is the same as the sine of the angle. For the purpose of your GCSEs though, the best formula to memorise for the parallelogram is area equals base times perpendicular height. Okay, I hope you found that helpful. Don't forget to like, comment and subscribe if you enjoyed the video. And if you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams. And I'll look forward to seeing you in another video.